So in this video, we're going to be talking about how the nervous system works and how a stimulus transfers from cell to cell within the body. Before a stimulus occurs, we are in a state of resting potential. During this resting state, sodium-potassium pump maintains a difference in charge across the cell membrane. It uses energy and ATP in the form of ATP to pump positive sodium ions out of the cell and potassium ions into the cell. As a result, the inside neuron is negatively charged compared to the outside cell, and this difference in charge is called resting potential. Poking me to wake me up is considered a stimulus and is what starts the chain reaction. So once the stimulus is given, the action potential begins. Depolarization is the first step, and this is when the sodium channels open and allow sodium ions to diffuse into the cell. This inward movement of positive charge makes the membrane potential more positive and less negative. And the depolarization phase is a positive feedback cycle where open sodium channels cause depolarization. After this, repolarization occurs, and this is basically the reversal of the electrical polarity, which allows the potassium channels to open and the sodium channels to close, and rush out of the cell. And this basically changes the electrical charge of the cell. After this, hyperpolarization occurs, and this is where some of the K of the potassium channels remain open, and then the sodium channels reset. And this results from more potassium diffusing out of the cell than sodium that has diffused in the cell. So after hyperpolarization occurs, the stimuli gets transferred to the next cell. When action potential reaches the axon terminal releases molecules in a chemical form called neurotransmitters. The neurotransmitters travel down across the synaptic cleft and bind to the receptors of the membrane of the other cell. And if the other cell is a neuron, this starts the action potential in the other cell, and that's how the stimuli gets transferred from neuron to neuron.